What's happening, dogs? It's Mr. Allen, and we're going to be doing some compositions of functions in this video. Let's start off with g of f over here, and you see some slightly different notations, right? This means g of f of x, so there could be a little x right here, or it could be written as g of f of x. This is actually my favorite notation, like this example over here, because it reminds me that f of x is going into g for this one. So f of x goes in from my x's in g. All right, so we're going to have -2 parentheses, and in place of this x, I'm going to throw 3x plus 4. So 3x plus 4, and then we have the plus 1 is chilling right there. Okay, so I replace the x in g of x with my f of x function. Cool. Now I'm just going to distribute and do like some algebra 1 stuff at this point. So I got -2 times 3 is -6x. -2 times 4 is -8. And then we have plus 1. Combine my like terms. -6x minus 7. Boom. Diggity. First one done, dogs. First one done. How about this one over here? H of g of 2. So this time I don't have an x there. I have a number. Well, what do I do here? Well, first thing, I can either do the composition h of g of x and then substitute in 2 or evaluate when x equals 2, or my preferred method, because I don't have to do all this algebra, is I just plug 2 into g, and then whatever that is, I plug that into h, okay? So the first thing I'm going to do here is g of 2. So we're going to plug 2 in for x, so -2 parentheses 2 plus 1, that's -4 plus 1 equals -3. So that's what is going to go into our h function now. So I'm just going to take -3 and I'm going to do h of -3. So it's like a two-part problem, if you will. And I could have had this go then into f and be like f of h of g of 2, and then I'd plug that into f. So here we got h of -3. We're going to plug -3 in for all my x's. -3 squared plus -3 minus 5. And I've said before in some of my videos that I like to always put parentheses around a number that I'm substituting in or I'm evaluating with to show that I've done this substitution here, right? It's not a number from the original function. I'm plugging that in. So I have -3 squared. That's going to be +9, right? A negative number in parentheses. Squared is 9. And then we have -3 minus 5. So that's 9 minus 3 minus 5 is 1. Boom. Awesome. Beautiful. So my preferred method again, substitute 2 in for g, whatever that number is, plug that in into h for all your x's, good to go, right? It saves a bit of algebra and just evaluating at that point. All right, top guy here. So we got f of g of x. So now this one here was g of f of x. This time g is getting plugged into f. So we're going to have, let's see here, 3 parentheses, and then g of x, that's -2x plus 1. And then we have plus 4. So the 4 stays. All right, so 3 times -2 is -6x. 3 times 1 is 3 plus 4. That's going to give me -6x plus 7. Boom. Very similar. That's oddly similar. That's super darn close. It's kind of cool. It's crazy. I don't know. It's a coincidence that they're the same numbers and one's just a +7, one's a -7. But yeah, there we go. So plug in my g of x into my f. Here, 3 parentheses, -2x plus 1 is my g function, right? And then over here, it was the g function, -2. We plugged in f in for my x, and then it was plus 1. Okay, so that's the slight difference there between those two compositions. Don't mess them up. The one that's inside there is going inside the other function, which is why I prefer to write it like that. Helps me see it, all right? Last one here, we have h of f of x. Let's rewrite that first here. Let's do orange. So I'm going to rewrite this as h of f of x, so it helps me see it. Hopefully that helps you guys see it as well. And now let's just go for it. So, this one's going to be a little bit of a beast, okay? So we're plugging f into h, and it's squared. So some classes will have you do this. Not all of them will go this crazy, but who knows? We're going to go crazy. We're going to go crazy here, okay? So this is going to be squared. And then we have plus 3x plus 4. Cool. And then we have -5. Okay. So I plugged in 3x plus 4, my f function, for all of my x's, my 2 x's there. And now I need to expand this guy right here. So I'm going to do, in a different color here, a little bit of math, okay? And I'm going to ignore this stuff for right now. So this right here, I'm actually going to do it over here, which will be in my face here in a moment. It is going to be 3x plus 4 times 3x plus 4. That would be the proper way, I think, to write that out. So you can see that, oh, I need to distribute. I need to FOIL, right? So 3x times 3x is 9x squared. 3x times 4 is going to be 12x. Then we have 12x this way. And then, oops, don't forget my x. 4 times 4 is 16. And then I'll clean that up. We got 9x squared plus 24x plus 16, okay? So some of you are going to be okay doing that in your head. Awesome if you can. If not, it's okay. You can just write it all out, FOIL it out, or distribute, however you want to call it. Now we're good to go. So now let's pop back into this problem here. We have our 9x squared plus 24x plus 16. These parentheses do not matter. If there was a coefficient here, I would have needed to distribute it. So I have plus 3x plus 4 minus 5. Okay, now we got to pay attention to our like terms. So 9x squared doesn't have anything, so that's just 9x squared. But I have 24x and 3x. That's going to give me plus 27x. And then I have 16, 4, and negative 5. Well, this right here is negative 1. So it'd be 15, 16 minus 1. We're going to think of it as 16 plus 4 is 20. 20 minus 5 is still 15, right? There's a couple ways to look at that. Again, I like to practice my mental math and then check it with the calculator because usually, not usually, a lot of times, frequently, your brain is going to be faster than you getting out that calculator, typing it all in if you practice that mental math. So I'm always going to encourage you guys to practice that mental math. If you can even see me right now with all this math on this board here. But anyways, thank you guys for watching. Hopefully that helps. If you need any other videos on compositions of functions, let me know. But I'm going to do some with some graphs, some tables, and let's see what else. Graphs, tables, and a function as well. And do some fun little things there. So thanks for watching. Make sure you like, subscribe, spread the word, man. Have a great day.